Hello, today we are going to be working on proportions. Proportion is basically just two equivalent ratios. And usually we have a missing term that we're trying to fulfill so that we can find out what the missing term is. So today we're going to be just checking to see if those two ratios, not finding a missing term, we're just going to see are they proportional, are they equivalent, do they relate to each other. The essential question for today is how do I know if two ratios are proportional? The standard is 6 ratios and proportions 3. And the question you should be able, like I said, to answer is how do I know if two ratios are proportional? Also, you should be able to solve real-world problems using ratios and proportions. So we're going to begin in our star that we have here, this fancy little star, and this is where we're going to write our, first we're going to write what is a proportion. A proportion is basically two ratios that are equivalent. Okay. So an equivalent, we understand, means they are the same. So when we're doing this, there's two ways that we can check to see if they are proportional. So the first way is we can look at the proportional relationship, which is a fancy way of saying, can we find a pattern that relates the two together? And I like to look for a proportional relationship first because I find that it's the easiest way to do it, but the problem is it's not always prevalent. It's not always there. So we can look at, for example, 1/2, and we want to know, is it proportional to fourths. So we can look at 1 goes into 2 times. So I can multiply 1 by 2 and I get 2. Can I multiply 2 by 2 and get 4? Yes, I can. Therefore, they're proportional. You can also look at across. So if I have 1/6 and 3/18, I know that if I go 1 times 18, I get 18. 3 times 6 is 18. They're proportional that way. I know if I multiply 1 times 3, I can get 3. 6 times 3, I also get 18. Therefore, they're proportional. So you can look at the proportional relationship this way. You can look at the proportional relationship this way. You can look at it all the way across. So any way around it, if you're finding a relationship or a pattern, you can use that as a way to see, yes, they're proportional. Okay. Now, unfortunately, though, that doesn't always work. Sometimes it's a little complicated to try to do that. And in that case, we have to go to step number 2, which will always work for you, and that is the cross multiplication way. And with cross multiplication method, you are going to look at it across. So looking at that problem that we did above, where we could just look at, 1 times 3 is 3, 6 times 3 is 18, we could also do it the cross proportional way, which is we could go 1 times 18 equals 18, and then 6 times 3 equals 18. And if these two numbers are the same, it is indeed, yes, proportional. But they've got to match up. If they don't match up, it's not proportional. So in any of these ways, you know that those different ratios are indeed proportional. They do relate to each other. They are equivalent. Once again, if I were to have like 6 times 4, and that would equal 24, and 1 times 18, you would notice those are not proportional because they do not match up. Here, once again, you look at the relationship between the numerator and the denominator, and whatever relationship is happening here, that relationship should also happen over here. You can also look at across. 1 times 3 is 3, 6 times 3 is 18. That also shows you that there's a proportional relationship there. So either way would work. Okay, so now let's do some practices. to see if we are aware of how this is really working and if we can apply it. So the first one is we have 2/9, and I write them like this, 2/9, and we have 1/5. And we want to see if these are proportional. So first thing I'm going to do is I'm going to look at, is there a proportional relationship that I can use? First of all, 2 does not go into 9 evenly, so that doesn't really work for me. 2 divided by 2 is 1, but 9 divided by 2 is not 5, so that kind of thing doesn't work. So the last thing I'm going to do is I'm going to see, can I look at it a cross multiplication way? So I would do 2 times 5, which is 10, and I would do across this way 9 times 1, which is 9. Now these are not equivalent, therefore this is not equivalent. And when I say it's not equivalent, I do this means equivalent, and this means it is not equivalent. So that one is definitely not equivalent, because we tried looking at it proportionally, it didn't work. We tried looking at it cross product way, it did not work. Therefore, it is not equivalent. All right, let's do the next one. 3/4 and 6/8. So we write it across. All right, let's look if there's a relationship. I can't use 3 and 4 as a relationship vertically. Let's look horizontally. 3 times 2 is 6. 4 times 2 is 8. That works. So once again, I did 3 times 2 is 6. Whatever you do to the numerator, you do to the denominator. 4 times 2 is 8. Therefore, it is proportional. But let's see if we could do it the other way, where we do cross product. We could do 3 times 8, which is this way, and that would be 24. We could do 4 times 6. That would be 24 as well. So yes, it also shows that it's proportional. Either way would work. You just need to show me which one you're using. I don't really care which one you do, as long as you are using one of them and you're showing your work. All right, let's go over now to page 63. On page 63, the first thing we want to do is we want to say that today on 11/9, we are taking notes, so we can keep a track of when we're going back to these notes. All right, so we took notes. And now you're going to look at the problem here. All right, so are they proportional? I want you to try this one out on your own. You're going to do 3/4 and 2/3. And I want to know, is it proportional? So you're going to do that one on your own. And then down here, I'm going to skip it. You could pause if you wanted and go back and just do that right now, but I'm going to give you some information on this one. Let's look at this problem. Julie bakes a cake. She uses 1 cup of flour for every 2 cups of sugar. So 1 flour to 2 sugar. Okay. Joe bakes a cake and uses 2 cups flour for every 4 cups of sugar. Okay. What is the ratio of flour to sugar for Joe's cake? So we've got Joe here and we've got Julie's in simplest form, and are the ratios proportional? I want you to solve this using your knowledge. You can even go back to yesterday's notes and double check that, but I want you to answer these 2 questions on your own. All right, well, go back and rewatch the video if you need help. Otherwise, you can email me or see me before or after school. I hope you have a great day. Bye.